This is then keywords to learn for the sound topic. Now, there's a big topic like this in year 11, and there's actually a fair few keywords on this one. A device made or for making sounds louder, right? Amplified to increase the amplitude of a sound so that it sounds louder. Okay, that is an amplifier. The distance from the middle to the top or the bottom of a wave. Okay, so there's your wave. The amplitude is that distance there. The range of frequencies that you can hear is audible. Audible is all to do with listening. The passage in the ear from the outer ear to the eardrum is the auditory canal. Think about your structure of the ear. The electrical signal travels along the auditory nerve to the brain. God, it's stupid, isn't it? It's got it there. Auditory nerve. A snail-shaped tube in the inner ear with the sensory cells that detect sound. Cochlea. Okay, it does literally look like a snail shell. The part of a longitudinal wave where the air particles are close together. So a longitudinal wave looks like that. And that bit there is the compression. The top of a wave, okay, diagram at the top right here, is the crest, or it sometimes can be the peak. A commonly used unit of sound intensity or loudness, decibels, okay, so over 100 decibels is kind of quite painful. The part of a microphone that vibrates when a sound wave hits it is the diaphragm. It's a bit like the diaphragm you have in your body. The organ of the body that detects sound is your ear, right? You need to know your structure of your ear. A membrane that transmits sound vibrations from the outer ear to the middle ear. Okay, so what you've got is you've got your outer ear. Okay, I can't draw actually. Sound then goes from your ear down the tube there and it hits the eardrum at the end. A reflection of a sound wave by an object is an echo. Is needed to make things happen. That's not a very good definition. Energy. The unit of frequency, hertz. The wave coming from a source of light is the incident wave. Sound below a frequency of 20 hertz is infrasound. That's then sounds that we can't hear. The semicircular canals that help you to balance and your cochlea is only the inner ear. Okay, so there's 3 of those semicircular canals that actually help you balance. 1, KH/Z equals 1000 hertz, so K is kilohertz. A wave where the vibrations are in the same direction as the direction the wave moves, longitudinal. How loud you perceive a sound of a certain intensity to be is its loudness. The material that affects light or sound by slowing it down or transferring the wave is the medium, so that's the substance that it's in. A device for converting sound into electrical signals, so I'm talking into a microphone at the moment. The ossicles, hammer, anvil, stirrup, are the small bones that transfer vibrations from the outer ear to the inner ear. Here's middle ear, so outer, middle, inner. Oscillations, something that moves backwards and forwards. Okay, so if you've got a longitudinal wave, it's literally going backwards and forwards all the time. Oscillations. A device that enables you to see these oscillations is an oscilloscope. Lots of kind of similar words here. The small bones of the middle ear, hammer, anvil, stirrup, that transfer the vibrations are the ossicles, and it's said it further up here. The pinna is the flappy bit on the outside of your head. The auditory canal and the eardrum is the outer ear. The membrane that connects the ossicles to the cochlea, so after it's kind of gone through the ossicles, there's something called the oval window. The outside part of the ear, the flappy bit on the outside, is your pinna. A property of sound determined by its frequency is its pitch. So high pitch has got a high frequency, low pitch has got a low frequency. The part of a longitudinal wave where the air particles are spread out is rarefaction. So what I've got is I've got my wave like that. So the compression is the bit where they're all squashed together. Those lines should be the same length. A rarefaction is where it's rare, right? There's very little there. The device that absorbs sound waves is a receiver, like a microphone is a receiver. The wave that is reflected from a surface, reflected wave. The The change of direction of a ray of wave after it hits a surface, reflection. A series of compressions and rarefactions that move through a medium is a sound. The speed of light, or a distance light travels in 1 second, 300 million meters per second. That's pretty quick, speed of light. The distance sound travels in 1 second, 330 meters per second, slightly different between the two, speed of sound. A device that gives out light or sound is a transmitter. The vibrations are at right angles to the direction of the wave, okay, so that is one of those waves, a transverse wave. The bottom of a wave, okay, so what we're doing here is we're not just doing sound, we're kind of doing light in here as well. So the bottom of a wave, that bit there, is a trough. I always think about pig's trough. Sound at a frequency greater than 20,000 hertz, that's higher than we can hear, is ultrasound. A space in which there is no matter, vacuum, that is then where no sound can travel through it. Backwards and forwards motion of the parts of a liquid or a solid, vibration. The pieces of skin that vibrate to produce sound, what I'm doing at this moment in time, is the vocal cords. Now there's a lot of words in that one then, okay, a lot of words, right, but it's kind of the structure of the ear, and it also brings in a bit of light as well, right, which isn't a bad thing. Pause the video on each one, write down the answers into an exercise book. Try and get them all right, obviously. Right, now you test yourself on all the keywords. Awesome if you got them all right. If you got them all right, do it again. If you didn't get them all right, do it again. Well done. Huge numbers of words in that topic then, okay, but all absolutely vital in your physics.